So as you can see in this first example, you have on the left side, you have an oxygen with no formal charge and an oxygen with a negative formal charge. You go to the other structure, again, you see an oxygen with no formal charge and an oxygen with a negative formal charge. And so what's really changing for those of you who are like, isn't that the exact same thing? In a way, it kind of is, but it's not. So if this is oxygen 1 has no formal charge, and then the other one, oxygen, has a negative formal charge for oxygen 1. Oxygen 2 has a negative formal charge here, and oxygen 2 has no formal charge here. But you can see that they're equivalent, and the structures are equivalent. Why? Because on the structure on the left, one of the oxygens has no formal charge, and the other oxygen has a negative formal charge. The structure on the right, you have an oxygen with no formal charge, and again, it's oxygen with a negative formal charge. What's changing is, on the scenario on the left, oxygen 1 has no formal charge, oxygen 2 has negative formal charge, and then it flips on the right. Oxygen 1 has a negative formal charge and oxygen 2 has no formal charge. Because of that, you can see that they are equivalent or equal contributors. I've seen both names, equivalent contributor, equal contributor. So just know I'm saying them interchangeably. Now, what would be the resonance hybrid? So the resonance hybrid is like an average between the two structures. If you can notice that what you see is in dash here is you have a double bond here and you have a double bond here. And so this dashed line is kind of representing how you could have, like, again, a hybrid of those double bonds showing on there. This is just the representation and drawing. And again, the negative charge to show that the negative is dispersed between those two oxygens. Okay, so that would be your resonance hybrid. Again, it's like the average of the resonance structures. Now, in this following example, you can see nitrogen and 2 oxygen. Again, oxygen 1, no formal charge. Oxygen 2 has a negative formal charge. On the structure on the right, oxygen 1 has a negative formal charge, and oxygen 2 has no formal charge. Again, they are equal contributors or equivalent contributors. And again, the resonance structure would, again, show that hybrid between both of them. So again, the double bond here and the double bond here kind of show how it goes along in that case, and again, how the negative is being shared between those two oxygens. Now, in this last example, again, what's changing is which carbon is receiving that positive charge. So it's not the same thing. So this carbon would be this carbon here. So carbon on the left has no formal charge, and then that carbon has a formal charge on the right. And again, this carbon has a carbocation, a positive formal charge, and then on here it has no formal charge. So again, what's changing is the carbon receiving or not receiving the formal charge, if that makes sense. So again, it is an equal contributor, and the resonance hybrid will look as following. Notice that now it is a positive charge because it's the positive charge that is being shared between both of those structures. Again, the resonance hybrid is the average of those structures. So I hope this video helped you at least see what and why you would have an equal contributor and what a resonance hybrid is. And if you enjoy this content, please like, follow, share, and thanks again for watching.